So if you've done a few projects in Pygame, you may have noticed that a lot of the kind of like beginning code looks the same, right? So I went ahead and created this little template project called Pygame project, and that is on my GitHub repo that you can get to at github.com/notasui. But basically it has this main.py file that I, by and large, base pretty much everything that I do in Pygame on. There are a couple things here that I don't actually need, but we'll get to that here in a moment. What I'm going to do is just create a new template, and I'm going to create a new repository, and that's just going to be aim trainer. And this is just a super easy name for this, obviously, and for my description I can just say simple aim trainer game using Python Pygame. And of course we will make it public, and I think that that is pretty much good. So now we have the new repo, and it's kind of like a fork, but rather than saying it's a fork and it has the same name and stuff like that, it just has a new repo name, and it says that it's generated from Notasui Pygame project, which is completely okay with me. So what I'm going to do is go ahead and copy the SSH aimtrainer.git and clone that locally. So now I've opened this in VS Code, and we can basically see our boilerplate code right here. The README needs to be changed, of course, because now this is just going to be aim trainer, and we will have, for now, simple aim trainer using Python Pygame. And we can just save that. So we do have a couple folders that basically have nothing in them. Instead of going through the process of basically opening Photoshop and creating a bunch of different files, I'm going to go ahead and just dump the graphics that we're going to use for the aim trainer in this directory to save some time. So now I have copied in a few different images. One of them is just a simple target. As you can see, this is just a 60 by 60 red square. And then our background is literally just a 1920 by 1080 background image that is all black. We can go to our settings.py, as we use in quite a few different Pygame applications, and basically see that 1920 by 1080 is the resolution that we'll be using here. Of course, I will change the title string to aim trainer, and we can leave the frames per second as 120. So I'm going to go ahead and minimize graphics, get rid of this audio goes here file. We will actually place some audio in there in a bit. But what I'm going to do now is basically talk about the system design here. Now, we're going to go through main.py, and of course we always have this maintain resolution regardless of Windows scaling settings. There are a couple things that I don't need, and I think that I mentioned that. One of them is delta time. I also do not really care about my start time, actually any of these time variables at all. So I can go ahead and remove them all, and we'll have a pretty simple game loop right here. So in basically an aim trainer, right, what's going to happen is that we're going to spawn a bunch of random targets. As you can see, our target is very simple, but we're going to spawn them randomly in the actual play field, and then it's going to be up to the player to basically click on them. And when the player clicks on the square or the target, it will simply disappear and a new one will be spawned on the play field. And so we'll basically have to record each time a player A clicks and B successfully destroys a target by clicking on it, right? So if a player clicks to the left of it or something like that, that is not going to be considered a hit. It will be considered a miss, and that should actually count against the player's accuracy. So we'll have to worry about how scoring works later on. And for now, I'm going to go ahead and save main.py, and we're going to worry about the countdown functionality, because really what happens is we need to have an amount of time that the player can actually go and shoot the targets in, right? So for testing, I thought 5 seconds was a good amount of time. For an actual like fun game experience, it'd probably be around 10 seconds, maybe more. But for testing, I'm going to be doing 5 seconds. That makes the time component a little bit more digestible when doing troubleshooting and things of that nature. So I'm going to create a new file, and that's going to be called countdown.py. And we're basically going to talk about how we would accept an amount of time in this class that we're going to create called countdown. There are several imports that we need to do prior to creating our class, and that's just going to be from settings, import star, and then we're also going to import pygame and random. And so now I'm going to create my class countdown, and we're going to have our init function, def init, self, and seconds. And then finally, we're going to have quite a few different things here. We need our display surface, right? So self.display surface is going to be equal to pygame.display.get surface. And then we will have self.font equal to pygame.font.font. And I'm going to have to create a new variable within settings called countdown font. But we're going to make that size 80 for now. And then I'm going to have self.decrement time equal to pygame.time.getTicks. And this is basically going to tell me when we actually start removing time from the amount of seconds that we initialize here in the init function. And then I'm going to have a self.shouldDecrement, and that's just going to be a boolean. I'm going to set that to false. Then I will have a self.time_left equal to int seconds, and self.initial countdown length equal to self.time left. Because when we restart this, if the player wants to restart, we need to know what to set this back to, rather than just, we could just remove the constructor and then create a new one. But I think we can basically get away with using the same countdown over and over again if we just reset to the initial countdown length. So in the case that we create a new countdown class that is 5 seconds long, then this would just stay 5 seconds, and when we reset it, it will always go back to 5 seconds. And then I will do a self.target group, and this is just going to be a sprite group, right? So pygame.sprite.group. And then I will have a self.targets spawned equal to 0. And this is just going to keep track of how many targets there were, and this will help us to identify what the score was that the user got at the end of the play session. So then we're going to have a couple of cooldowns. So def cooldowns, self, and we're basically just going to get the current time, of course. So cur time is going to be equal to pygame.time.getTicks. And I stand corrected, there's actually only one cooldown. But basically what we're going to do is see if we should still be removing time from time left. And the way that we can do that is if not self should decrement and self.time left is greater than 0 seconds. We will then check if cur time minus self.decrement time is greater than 999 milliseconds. Then I will self.should decrement equals true. So basically this will mean 1 second has passed, right? So if 1 second has passed, I should decrement another second. So this will give us a nice kind of like 10, 9, 8, but of course it's going to start at the number of seconds here. So then we actually need to draw the timer to the screen. And basically what we're going to do there is just have a new function called def draw timer, and that's just going to take in self as a parameter, and then we will have if self.should decrement. What we're going to do is self.time left minus equals 1, so we're just going to subtract 1, and then we're going to change self.decrement time equal to pygame.time.getTicks, which will then update what its value was during the initialization function. And then we'll self.should decrement, we'll set that to false. So that means that the cooldown will start and basically wait for a second to pass to set that back to true. And then we're going to do another if check, and that's going to be if self.time left is greater than 0. We will then count string. We're going to create something called count string, and that's going to be set to the string value of self.time left. And then finally, We're going to have an else statement that just says count string, and we're going to set that to nothing. Once time left ends up being 0, then we're just going to have a blank count string. So I'm going to have a note here that says draw current value of count string. And that's just going to be count surf equals self.font.render count string true text color and none. So I can't remember off the top of my head what the 4 different parameters are, but I know that when we use our font, which is stored as self.font, we're then going to render our actual string, which is going to be the value of count string. Again, I can't really remember what this true is. Text color, that needs to be defined in settings, and I believe this is transparency, so we have no transparency there. Although I could be wrong, I'm not 100% sure what this is. In any case, what we then need to do is have an x and a y equals width minus 20 and height minus 10. And you'll see this here in a moment, but if we go back to the bg.png, that basically is going to take the values here and subtract a little bit to them. So our timer is going to be right here in the bottom right of our screen. So it'll be out of the way of our actual targets and our playfield and stuff like that. So then we're going to do count rect. We're going to create a rectangle. And that's going to be set to count surf dot get rect, and the bottom right is going to be equal to our x, y. And then we're going to blit that onto the display surface. So self.display surface.blit count surf, and we're basically going to place that on the count rect. Cool. So that should handle our timer. And basically we need an update function as well. So we're going to do def update self, and we're just going to have our self.cooldowns and self.draw timer. And again, we have 2 things we need to define. So countdown font and text color. We will do that in settings. So text information, or text config rather. So we'll have this countdown font equals graphics font, and then I have used a font that's kind of like the Red Dead Redemption font that I think is pretty cool, and that is called deathcollege.ttf, and I believe I got that from DeFont. So font from DeFont. But you need to make sure that this is in graphics font, and basically this will be whatever your font file name is. So that will be right here, deathcollege.ttf. And then I can basically go back to countdown and get my text color. And I will define that as well. And that is just going to be white. And I'm also going to define a font size value of 300 for good measure, because we actually are going to use this a couple of different times. And while we're in settings, I'm going to have some images, and we have not actually defined where our bg.png is, I don't think. So I'm going to have a bg image path, and I'm going to set that to graphics bg.png. And then I'm also going to have my target here, so target image, and that's going to be graphics target.png. So let's just get all of our settings out of the way, and I believe that should do it for the remainder of the Aim Trainer video. So I'm going to go back over to countdown. I'm going to make sure that everything looks right. So now we should be able to create a countdown object within main.py when the game starts. So if I go back into basically our general setup here, I need to define a couple of different variables. One is going to be self.click_count. So this is going to keep track of how many times the player actually clicks during the game. We're going to set that to 0. And then I'm going to have a new section here, and I'm just going to call that background image. And it's going to be self.bg_image equals pygame.image.load bg image path. And lastly, we will have our create countdown, which will just be self.countdown equals countdown, and then we need to add the amount of seconds. I'm just going to put 10 for now, and we basically need to import countdown. So from countdown, import countdown. And in our game loop, we will need to have game-specific updates. And I'll just put self.countdown.update. With a little luck, we should be able to run this and get our countdown in the bottom right of the screen. And there we go. However, we have an issue because this continues to draw over itself and doesn't really look very nice. So let's go ahead and figure out why that's happening. So I'm going to actually add something right here that basically just redraws the background image, and that will just be self.screen.blit self.bg image at the location of 0, 0. And I believe that should take care of our issue. And it does. So we have this nice little countdown in the bottom right-hand corner. Of course, once it reaches 0, let's see what happens. Nothing. Okay, so this is a very boring aim trainer thus far because we're not spawning any targets, we're not keeping score. So first of all, before we start the countdown, it would be nice if we had like a start screen or something like that that basically says aim trainer and then allows the player to press a button or something like that when they're ready to actually play. So I'm going to go ahead and create a new class, and we're going to call that title.py. And in title.py, I need to import a couple things from settings, import star. And then I'm also going to have import pygame, of course. So I'm going to then create class title screen, which will have its own init function, def init self. And I will then, of course, have a display surface. So self.display surface equals pygame.display.get surface. Then I'll have a font as well, self.font equals pygame.font.font, countdown font, and then that's just going to be the 300 font size that we set in settings.py. I will then have self.space font, and that will be smaller. It's going to be a little subtext that we have, so that's going to be pygame.font.font, countdown font, and then we're going to set that to 60. And then we're going to have an update function, so def update. And what I'm going to do now is basically load background image and create text objects. So title image will also be background.png, so equals pygame.image.load. And then we'll have background image. What is that called? BG image path, rather. Then we'll have a dot convert alpha. I think I need to do this elsewhere. But then I'll also have basically a press space text. So press space text equals self.space font.render. Then I'm going to have an f string here. Press space to start. And we're going to have the true. Again, I don't actually know what that is. And then we're going to have the color, and I believe I actually set that to an RGB value. That's just going to be 25500, which should just be red. And I think that is good. So we also need the aim trainer text as well. So I'll have aim trainer text set to self.font.render. And that's just going to be aim trainer in all caps. And we'll set that to true, and this is going to be white, so 255, 255, 255 is going to be our RGB value there. And so then we're going to move on to our next section of the update function, and that's just going to be creating our rectangles. So create rectangles from text objects, and that's going to be aim trainer rectangle equal to aim trainer text dot get rect, and then finally press space rect equal to press space text dot get rect. And so now we need to actually set their locations, right? So we can print them in the right place. And this is kind of messy, but it will just be aim trainer rect dot center x and aim trainer rect center y. We're going to set that equal to self dot display surface dot get rect, and we're just getting the center of our screen because that's where we're going to basically print out this text, right? So center x, and the same thing, self dot display surface dot get rect dot center y. And then I'm going to do the same exact thing for press space and draw self dot display surface dot blit title image at location 00 self dot display surface dot blit aim trainer text aim trainer rect is the location self dot display surface dot blit, and then we'll have our press space text on the press space rectangle. Cool. So let's go ahead and basically instantiate our title screen, which means we need to go back over to main.py and then have another import here that's basically going to be from title import title screen. And so when we have our create countdown, I guess we can just have create objects of relevant classes. So I'll do one similar here, self dot, and then I will basically just have that be title equals title screen. And now we have kind of an issue, right? Because we have, if I do an update here in my game loop, then they're going to be conflicting, right? Because I'll be counting countdown and title screen every single frame. And both of those have their own draw functions, right? So we don't want them like drawing stuff at the same time. We basically want to have different states of the game. And so there are a couple ways of doing this. I'm probably going to use not the greatest way of doing this, but what I can have is a game state variable that's just going to be a string, all right? And I can actually declare that up here, self.game_state, and I'll basically put that as waiting, all right? So we're going to start the game, and it's not going to actually count down yet. We're going to be in the waiting state. And so what I'm going to do then is basically listen for a key press of the space key. And so if we go back over to title, we have that press space to start, right? So we're going to listen for the space key. And when we have a space key that gets pressed by the player, then we'll basically change the game state to playing. And when it's playing, then we'll go ahead and do our self.countdown.update. So what I'm going to do now is just have an if statement that says if self.game_state equals waiting, we'll have a self.title.update, right? And that's going to draw our title. And if it's not waiting, we'll have an elif self.game_state equals playing. And then we will basically have our self.countdown.update. So we're going to have basically a game over state as well, but we'll worry about that in just a second. What I'm going to do at this point is go up to our while true for event in pygame event.get. We need to basically look for an event type of a pygame.k_space. So rather than the event type pygame.quit, we're going to be looking for elif event type equals pygame.keydown and self.game_state is equal to waiting. What we're then going to do is check if the event.key equals pygame.k_space. We're going to create our countdown. So we can actually remove this because we're going to do it. Well, we can move it to this location. And of course, I need to worry about where the indentation is. But I will create my self.countdown, and I will set that equal to our number of seconds. And this is where I'm going to change it down to 5 because I'm going to be running this a lot. And if it's 10 seconds every single time, that's going to be quite annoying. And I'm also going to change the self.gameState to playing, which again, every single time this game loop runs, basically it's going to do an if statement that's looking for the game state, right? And if we're waiting, it's going to do the title screen, and if it's playing, it's going to be the countdown. So if we run this, we should get a title screen. And we do. Now we notice that the press space to start is in the wrong place, but if I press space, I actually jump to the countdown, which is exactly what we wanted. So let's go ahead and fix the spacing on the title screen. And that should be relatively simple. I think we just need to add 150 or so to the center Y of our press space rectangle. So I can go ahead and do that with just plus 150. Let's go ahead and try that. Nice. So that is the spacing that I wanted to go with, and our countdown is ready to go as well. So one thing we'll notice is that this thing just goes blank at the end. We don't actually have any logic as to what we should do once the countdown reaches 0. So let's go ahead and work on that. So back over in main.py, we can go back to this elif self.gameState equals playing. So we can add something to this, and that's just going to be and self.countdown, and we can access the variables within the countdown class through our object, right, which is just self.countdown. So I can then check time left, and I'm going to make sure that's greater than 0. So if that's greater than 0, then I'll continue to do my self.countdown.update. However, if it is equal to 0, we'll have another statement here that says elif self.gameState equals playing and self.countdown.time left equals 0. We need to basically have a new game state, right? And that is going to be self.gameState equals game over. And then we're also going to have a new class that we create here, and that is going to be called postGame. And what we're going to do for that is just self.postGame equals postGame, which doesn't exist yet, self.clickCount, which we do have in our main.py up at the top in the init function. We also need to get our target spawned, which is going to be in the countdown object, so self.countdown.targets spawned. And we're not going to count the last one because basically there's always going to be, after a, let's just say, you know, the player clicks one target, and then another one spawns automatically, and then the game ends. We don't want that to count against the player because they didn't really have time to click that last target, so we're just going to subtract 1. And then finally, I'm going to have a little note here that basically says total clicks and total hits, because I was trying to do some math when I was coming up with my score, and I wanted to make sure that I had the nomenclature right, like total clicks and total hits. In order to get my percentage of accuracy, I basically want to take the total hits and divide that by the total clicks, right? So if I clicked 10 times and I got 9 of them actually hit the targets, then that would be a 90% accuracy. And yeah, so I need to actually create our postgame class, and I will do so by creating a new file in here, and that is just going to be called postgame.py. So in postgame.py, we basically need to check our settings, and we'll do that from settings, import star, and then we're also going to import pygame. And that should do it for the imports, and now I can just create a class called postgame, and then we'll have our def init. And we need a couple things here, self, total clicks, and total hits. And we will basically do the same thing that we do most of the time, which is self.display surface equals pygame.display.getSurface. And then we will also have our self.total clicks equals total clicks. And we can add total hits on this line as well. So self.total hits is going to be equal to total hits. Following that, we'll just have a self.misses equal to self.total clicks minus self.total hits. And that'll just be an easy variable to know how many items that we missed, or rather targets that we missed, and that's going to actually come out of the player's score once we start coming up with the method that we use to score. And then we'll have a self.font equals pygame.font.font, and this is going to use our countdown font again. So we'll have our font as well, which is going to be the font size of 300, which is in settings. And then we're also going to have a self.base font size, because I want to have a score that basically creates a larger font the larger the score. Because it's just a little bit more interesting, and it's kind of like a visual incentive for the player to get a higher score, right? Because they get like this cooler looking output score at the end of the game. And that basically means that our score is going to be output at a font size of 60, and that's just going to be the base font. As the player gets a higher score, we will add to this number, and we'll have a function to do that. And we're also going to have a multiplier, self.multiplier equals 1. And so basically the number of targets that the player gets will add to this multiplier, which will ultimately lead them to a much higher score. So what I'd like to do is increase our multiplier based on the number of total hits, and we'll have a penalty if we have misses, right? So I will increase multiplier based on number of total hits, penalty for misses. And so I can do this with if self.total hits is greater than 1. We're basically going to have our self.multiplier equal to self.get new multiplier, which does not exist yet, but that's going to take two input parameters of self.total hits and self.misses. So we need to create that function. We'll do that here in a moment. We're then going to have a self.score font, and that will be pygame.font.font, countdown font, self.base font size. And here's where we're going to have a little interesting math equation that will help us get our font, and that's just going to be 7 times self.total hits. And so basically our score is going to start at 60, all right? So base font size, and this needs to be a plus. So for example, if a player gets 10 hits, then we'll basically have 60 plus 7 times 10, or 70, and we'll have a font size of 130. And I can't remember how I came up with this 7 number, but after a couple of tests, it just looked the best. So yeah, we will then have a self.stats font, because we also want to display some statistics at the end of the game. And that will just be pygame.font.font, countdown font, 60. So this could just be our self.base font size. So then we want to get our accuracy, our final score, and yeah, those variables need to be used so we can output the stats at the end, right? We do want to check to make sure that the player actually did click at least once, otherwise this will be kind of boring. But if self.total clicks is greater than 0, we're going to create a self.accuracy, and then we're also going to have a self.final score. We'll define those in a second, but then we're going to have an else statement, and then we're just going to have those variables set to 0. So self.accuracy and self.final score will just be 0. They'll each be 0. So our accuracy, again, is determined by the total hits divided by the total clicks. And I can basically do that. I need to do a round function. So I'm going to have round and self.total hits divided by self.total clicks, as mentioned. And then we're going to multiply that by 100. And the reason I'm going to do that is just to have like a larger score value, because it's, you know, cooler to look at like a score in the hundreds or the thousands rather than, you know, 10 or 20 or something like that. And I'm also going to round this to 2 decimal places. And after that, I can have my final score, and that is basically going to format this so that we have a comma as well if it is in the thousands. And I can do that with this cryptic little string here. I could not explain the actual syntax to you. I did actually Google this. Basically just said, how do I add a comma in the thousands or something like that. But yeah, dot format, and then we'll have the integer value of self.accuracy. And basically the way that I thought scoring made the most sense is I would take my total hits and multiply it by the accuracy. So if I had a 90% accuracy, but I had 10 hits, right, then I'd basically have 900. So yeah, I figured the accuracy multiplied by the total hits would be a good way to determine the final score. And lastly, we will take this number and multiply it by self.multiplier. So right now, we don't actually have a getNewMultiplier function. We need to go ahead and create that. And then, of course, we'll just be def get new multiplier. And that will take self num hits and num misses. So basically what we're going to have here is a basis. Ooh, of course, this needs to be def. So we're going to have a basis variable, and that's going to be set to the num hits minus the num misses. So again, I did want to have a penalty for misses, right? And we're just going to take away from the number of hits. And basically, you know, if you have 9 hits but 1 miss, we're only going to give you a multiplier based on the number 8. So this actually does have a pretty significant, or potentially a significant impact on the player's score. But what we're going to do is if basis is greater than 3 and basis is less than 6, we're going to have a return 2. So this will just be a 2x multiplier. And then we'll have elif basis is greater than 5 and basis is less than 10. We'll return 3. You can kind of see where we're going with this. Elif basis is greater than 9 and basis is less than 15. We will return 4. And finally, elif basis is greater than 14. We will return 5. So this can have a, like I said, a very significant impact on the score. And we'll go ahead and start working on our update function. Def update, of course, just takes self. So what I'm going to do is load background image and create text objects. And I will have a postgame image set to pygame.image.load, and that'll of course just be our BG image path that we've used a couple times before. And then we'll convert that alpha. And then I will do game over text, and I'll set that to self.font.render game over true. And I believe this is 25500, which should be red. We'll then have stats numbers text, set that to self.score font.render fstring score, and then we're going to have our final score variable self.final score. And then we will have our common true, and then I think this one's going to be white, so true 255 255 255. And then I also want to have a different text block, and that's going to be stats percentage text equal to self.stats font.render. And then we'll have a similar press space to try again. And that will be true. And I think this one is going to be red. Actually, no, we'll have this as white as well. So 255, 255, 255. And then there is a chance that my score might be wider than 1920, right? So the width of the screen is 1920. We don't want that to go over, otherwise it'll look really weird. So we basically need to check to see if the width is greater than 1920, and if so, we need to scale it. So this is a little bit tricky, but we can do that with if stats numbers text dot get width is greater than 1920. That means it's too wide. We will then scale the image down and maintain aspect ratio. Actually, this is scale the score down and maintain aspect ratio. Okay, so that will then just look like new height, and we'll set that to an integer of stats numbers text dot get height divided by stats numbers text dot get width. Here's the aspect ratio that we're getting. All right, we need an integer value of that. And then we'll also need to multiply this by our original width of 1920. And that is going to give us the new height, so I can then scale that by doing a stats numbers text equals pygame.transform.scale. And then we're going to do that again on stats numbers text, and the new resolution will be 1920 by the new height. New height. And that should scale that the right way. And we shouldn't have any overage of the score if that works properly. So then we will have basically a new block here where we're going to create rectangles from our text objects. And that will just be basically game over. We'll have that game over text dot get bounding rect. And so get bounding rect basically ignores all of the space around a given surface, right? If it has no pixel data, it just ignores it. So it's kind of like a more compact rectangle, which I found works better for this particular font. That might not always be the case, but it is the case with this font. So then I'll have a stats numbers variable that's also just going to be stats numbers text.get bounding rect. And lastly, I will have stats percentage. You guessed it, equal to the same thing. Dot get bounding rect. All right, and now we basically need to get a height variable, and that's going to be the height of all three of those text blocks added together. Okay, so our get height function will give us that y value, or rather that height value, and then we can just store that as height. And what we're going to do is center basically the stats on our 1920 by 1080 background, right? So our final surface is just going to be that same size. Final surface. It's going to be a pygame.surface of the size 1920 1080. And then I will have a final surface rectangle set to the final surface dot get rect. And we're going to place that in the center, of course, the final surface rect dot center x. And I don't think I actually need to do this because it's going to be the size of the screen, but I'm doing it anyway. Final surface rect dot center y. And then, of course, we'll just have that self dot display surface dot get rect dot center x, and we'll do the same thing for the y coordinate. All right, and now we're almost done with this. This has been quite the update function, but we're actually going to blit this to the screen. So final surface dot blit game over text game over, and then we'll have our final surface dot blit, and then we will do stats numbers text stats numbers, and the final one, final surface dot blit stats percentage text stats percentage. And we will blit the post-game image and the final surface to the screen. So self.display surface.blit post-game image at location 0, 0. And also self.display surface.blit final surface at, again, 0, 0. All right, so that was quite the class that we had to create there for post-game. But we also need to go over to main and have something, or rather import to post-game, because we have not done that just yet. So I'll go ahead and from post-game import post-game. And we're not actually going to do, like, all the things that we have with our score we're not doing yet because we haven't actually done our target, which is going to be the last class that we do. And that one should be relatively simple with a little luck. But let's go ahead and run this and see what happens. All right, so all of these things don't actually get calculated because I didn't click at all. So what happens if I click once? Actually, I'm going to click a couple times. 1, 2, 3, 4, 5. Okay, still nothing. We'll go back over to main, and I think that's because we're not actually calling the update function. So we do actually create a postgame object, but we need to also have elif self.gameState equals game over self.postgame.update. So we'll then call that update function, which is responsible for drawing everything. So let's run this, click a couple times, again 5 times, and we'll wait for the timer to go down. Okay, so we do actually see a game over screen. It is in the wrong place for some reason. So let's go ahead and see if we can figure out why that is. So I spoke too soon. We actually were not done with our update function. When we did our height, we basically forgot to move our rectangles. So before we start actually creating our final surface, we need to move the rectangles in the right location. And we will do that by adjusting the rectangle locations to match final surface rect. Okay, so we're first going to do game over.centerx and game over.y equal to 960. So 960 is going to be half of our 1920 width. And then our y value is just going to be 1080 minus height divided by 2. And this all makes sense here once we have the spacing set correctly when this prints to the screen. But then I'm going to do a stats numbers.centerx and a stats numbers.y. Also going to be set to 960 on the x value, and then game over.bottom plus 20 pixels. So we're basically going to take the bottom of this rectangle, add 20 pixels to the y, which will give us a nice little padding between that and stats numbers. And then finally I'll have stats percentage.centerx and stats percentage.y set to 960 and stats.numbers.bottom plus 20. So that should resolve our spacing issue on our final surface, and let's give that a try. 1, 2, 3, 4, 5. Okay, our score is 0. Press space to try again. And press space, nothing happens because we're not actually doing anything in the case of the game state being game over. However, we do get the spacing that we like, and that is looking much better. So in main, when we are listening to our Pygame events, we basically need to have another scenario. And that is going to be when our key down is a space, but the game state is game over, right? So what I'm going to do here is have another elif event.type equals pygame.keydown and self.gamestate equals game over. And then I will reset the game state and clear click target details. I will then check if my event.key is equal to space, pygame.k space, and if that happens, I will basically say self.clickCount equals 0. I will then have a self.countdown.targets spawned, and I'll set that to 0. Also have a self.gameState, and I'll put that in waiting. And finally, I will get rid of my countdown instance or object, and that will be del self.countdown. So what will then happen in my game loop is that it will say, it will basically get this game-specific update, and it'll go back to this right here. So we'll go back to the title screen. So let's go ahead and run that and make sure that is what happens. 1, 2, 3, 4, 5. Of course, this is not counting against us. I don't know why I keep clicking. In any case, we get the game over screen, score 0, press space to try again. I will press space, and we can see that we actually do go back to the title screen. And then I can press space to start, and we'll get another countdown. So I'm going to close this, and basically what we need to do now is come up with our target class, and I will then create target.py. And in target.py, I'm going to need settings. So from settings, import star, and import pygame, and I will create my new class called target. And target is actually going to be pygame.sprite. So pygame.sprite.sprite. And when we inherit, we need to do our super within the init function. So def init self, and then I'm going to want an x coordinate and a y coordinate, and then I'm going to want a groups argument, and we'll see why here in a moment. But I'm going to super underscore init my groups as the args. And then finally, I am going to have some sounds here, so I'm going to have pygame.mixer.init. I'm also going to have a self.image equals pygame.image.load, and then I'm finally going to use my target image, which is again is the 60 by 60 red square. I'm going to have a self.rect equal to self.image.getRect, and that's just going to be a top left equal to our XY input value. And finally, I'm going to have some audio here that's going to be played to our mixer channel 5. And so without going through the process of me creating this really cheesy sound effect, I'm just going to copy it into audio. And that is it. And I also have my shot sound. They're both really bad, but I created them so I can provide them without worrying about any licensing issues. So I can go back over to target, and we can basically finish this by adding that audio. And I will do that with self.hit_sound, pygame.mixer.sound, and that's just going to be in the audio directory, and it's going to be hit.mp3. And I'm also going to change that to a different channel, because I found that if we're playing sounds quickly, if they're not in different channels, sometimes they can like interfere with each other, and it doesn't sound that great. So I'm going to have a self.hit channel, and I'm going to set that to pygame.mixer.channel5, which is a very arbitrary number, but it worked in testing, so there we go. Then I'll have an update function for this, def update, which takes self. And so here what I'm going to do is basically have a comment that says get the x and y coordinates of the mouse cursor and check for a collision. And if that is the case, then basically the player has actually hit the target, right? So x, y equals pygame.mouse.getPosition. And what I'm going to do is have basically if self.rect.collidePoint x, y, self.hit channel.play, and that's when I'm going to play my self.hit sound. And then I'm going to self.kill, which will then actually remove the pygame sprite. So this takes an x and y value, which we're not actually inputting just yet. We need to figure out where to do that. And I think that is going to be another function in our already existing countdown.py. And it's going to be here at the bottom, just above update. And we're going to call that spawn target. Self is going to be the parameter, of course. And I'm going to have a note here that basically says the target is a 60 by 60 pixel red square. And I need to spell square properly, of course. And what I'd like to do is check to see if there is time left in the countdown and spawn a randomly located target if so. If none are in sprite group. Because I only want to have one target. And there, you know, you could think of maybe a case where it would be cool to have multiple targets and things like that, but that is beyond the scope of this video. I would absolutely invite you to do that if that is something that you're interested in, though. So what I'm going to do is check to see if self.timeLeft is greater than 0 and the length of my list item for item in self.target group is less than 1. That means there are no sprites in my sprite group called self.target group. I'm going to basically say xy equals random.randint 0 1860, which is my maximum width of 1920, subtracting the width of the target, which is 60, right? So 1920 minus 60 gives me that 1860 number. And then I'll also have a random.randint 0, and obviously doing the same thing for the height of 1080 minus 60 gives us a number 1020. So then I'll have spawned target, and I'll set that to basically just a target object with my x and y, which are basically those parameters that we need when we instantiate a new target. And I'll have self.target group.add spawned target. So I'll add that to my sprite group, and then I'll keep track of my self.targets spawned plus equals 1. And finally, I will have my self.target group, and I will call draw self.display surface. And if you want some more information on how that draw works, you can basically see it here in the documentation. But it basically allows us to draw this to the screen, and of course that is our input parameter. If you go back here, self.display surface as the input there. And we're getting an error because we don't actually have this imported. So we'll go ahead and do from target import target. So now we can go back to main.py, and we need to actually have something happen when we click the target, right? Because right now we can spawn the target, I think. We haven't actually run this. Actually, let's run this and see what happens. It will probably break. Actually, it's not even spawning the target. Okay. So we're not calling that spawn target function, which makes sense. We need to actually put that in our update function. And I can simply do that as self.spawn target. Let's give that a try again. So we're spawning a target. Of course, nothing actually happens. We get a score of 0, and this game is really boring. So we'll clear this, and we will go ahead and go back over to main.py. And we're going to have some logic for a mouse click. We'll have another elif event type equals pygame.mouse button up. And self.gamestate equals playing. We will then add this to the number of clicks, so self.click count plus equals 1. So I guess we weren't even appending those clicks when I was doing it earlier, so that was a complete waste of time, but now it will not be a complete waste of time. I will then have self.shotsound.play, which we need to create, basically need to add that here in a second. I will then have a self.countdown.target group.update. And that will actually do the logic that we just added into target.py. And I don't think shot sound is actually loaded just yet. So this will cause issues. Background image and shot sound should resolve those issues. Self.shot sound equals pygame.mixer.sound audio shot.mp3. Now let's give that a try. All right, so we got a score of 2,100 in our game, which is pretty good. That means that we got a multiplier. Let's see what happens if I just get 1. If I get 1, I don't think I get a multiplier at all, which means it'll just be 1, right? So the score is 100. So I don't actually get any additional scores, or multipliers rather, until I get more than 3. So what happens when I get 4? 1, 2, 3, 4. All right, let's give that a try. Okay, so that's when the multipliers start to get a little bit interesting, right? And it gives people incentive to get more because obviously, you know, in a countdown scenario where you only have 5 seconds, it becomes increasingly difficult each one over, say, 7 or 8, right? So if you're getting above 14, which is the max multiplier, that is incredibly impressive and you're probably a pro gamer. But I am not. I am just someone who likes to write Python and Pygame code. So at this point, I am pretty happy with the aim trainer, and I am hoping that you're able to work through this. And if you have any issues or anything like that, please add them in the comments, and I will do my best to get back to you. If you decide to make this more difficult or use different graphics or different sounds or anything like that, I would love to hear about that in the comments as well. Thank you so much for watching, and I will see you in the next one.